Hello everyone, you join me today with an eBay find, a Marconi 6059A 12 to 15 gigahertz signal source. This particular unit was retrieved from a Ministry of Defence client. I think it was used on HMS Southampton, so it's obviously seen life on the sea. So I got it quite cheap on eBay. I didn't pay much for it, but I've been after something like this for a while. It's pretty unique. I'd say it was made in the 70s or 80s, possibly a bit earlier. So it did have a fault on it when it arrived, which I'm going to show you in a moment, but it worked nevertheless. We was given an output from the N-type and the frequency was correct. Slightly off, but you know, still almost correct. And it has a mechanical tuning, which is tuned by this wheel, and then we obviously have the gigahertz frequency, microwave frequency readout. We've got an external mod input as well if you want to modulate the output, either with pulsed modulation, FM modulation or phase modulation. We can do that through the external mod input. We also have an internal mod frequency oscillator which produces either a square wave or we can just have it carrier wave. We've got a line, a mains on and off, and then in here we had a neon indicator which sadly had popped and wasn't giving any light, so I've got to replace this. And what's strange about this is its voltage rating is far lower than the actual line voltage, so that may be the reason why this didn't last 2 minutes, and I think this has been replaced before, as you'll see with other things. Anyway, the second time I powered this up, the first time obviously it worked, it was giving output, I was quite happy, but the second time I powered it up, it tripped the mains RCBO in the workshop, and that wasn't an issue with the current consumption. It was the imbalance between the live and earth and the neutral and earth. And anyway, it looked like as if there was a fault, so perhaps that had not been picked up previously, or it was just a fluke. So I took it apart, which led to a what can be only described as a nightmare of epic proportions. And I'll tell you something about this unit. It's very, very well made. It's very heavy. It must weigh over 5 kilos. Anyway, this is internally. This is a main circuit board that's inside. Incidentally, all the op amps had totally black leads, so obviously that's the age. And the capacitors have all gone. They've all got crazy values, nothing like what they're rated at. So I'll come back to the PCB in a moment. But what we did have was something very worrying inside, indeed, very, very worrying. And that is that we had these reefer caps here that have obviously been added by somebody at some stage, goodness knows why. The only thing I can think of is that in this particular product, which I should download a service manual for, there was a mains filter connected here, and obviously there's a mains tag here for the earth, and this particular bracket was there holding those two caps in it. Would you believe they were actually inside the middle there, just loose, not really fastened down. So somebody's added that, and as you can see, the capacitor behind the electrolytic's got a similar bracketry arrangement, although albeit larger. So this is obviously meant for electrolytic capacitor. Now, on most products that we find today, because just to explain a moment, which I've missed, is that this reefer cap here, the green wire connected to the solder tag down here, and these two wires, one went to the live and one went to the neutral. And obviously we use these types of capacitors mainly in switch mode power supplies. That's where you tend to see them, because obviously in switch mode power supplies, the switching that higher frequency, the EMI regulations or EMC compatibility regulations prevent that switching frequency from leaving the unit on the mains lead at the back. Likewise, any interference coming in needs to be suppressed off so that it doesn't influence or end up on the output of the power supply in some way. Now, it's not normal that you find such filtering on equipment that has a mains transformer, be it toroidal or an iron core transformer like this, because they don't tend to suffer with that kind of a problem. Obviously, there is a possibility if there's a switch mode supply on the secondary output of the transformer, or some kind of high frequency switching at quite high levels of power, that some of that frequency can be inductively coupled through the transformer and thus leave the unit on the IEC lead. But it's very rare that would happen, and I can't see any evidence of that occurring here in this design. So I'm going to look at the service manual when I've downloaded it to find out what was originally there. I think if anything it's probably just a capacitive mains filter that was originally in by Marconi, and then it had a supply connection to the mains 240 volts. Now, one of the faults that was on this was that the level control at the front here that controls the RF output level wasn't working, and I'm not surprised. Based on the condition of the circuit board, it was very bad indeed. All these op amps were all black on the leads, and the caps have done. So I'm going to change those first. I've cleaned the leads on the op amps. As I say, I'm going to download a service manual and see what the adjustments do and try and calibrate it and repair it. And obviously put a new neon in. I've got plenty of these, so we'll replace that. But it's a lovely little unit, it really is. I've been after something like this for a while. It's just the retro feel of it, you know, and the quality and the manufacture. You won't get that today. And look at this, brass, solid brass, you know, it's wonderful. Really good quality. And it's mechanically limited as well. So when you turn this up to 15 gigahertz, it stops, and it's a mechanical stop. And when you wind it down, it gets so far down to 12 gigahertz, and then it mechanically stops again. So it's mechanically limited. Obviously this turns a cam here, which then pushes this plunger in and out, as you can see, as we're winding it up to 15 gigahertz from 12. Excuse me, it goes in, and thus for the low frequency it comes out, obviously. This is a gun diode oscillator, microwave oscillator, and the output of it comes out on an SMA connector on the side of the gun oscillator, and goes into this isolator, which has got a termination on the side here. This allows the microwave frequencies from the oscillator to pass through and leave, but any reflected signal coming back won't be allowed to enter the oscillator and cause instability issues, which is what happens when you get return reflected RF signals coming back. It can upset the oscillator, cause it to do all sorts of undesirable things. So any RF coming back this way gets dumped into the load and prevents its return to the oscillator. So it's a one-way path for RF is this. And then that's passed then to this stage, which is a pin diode attenuator. And this pin diode attenuator is used for two purposes. When you adjust the level control on the front, which I've just shown you, it changes the voltage on this wire, and the pin diode inside changes its attenuation. So RF passing through, obviously it's a fixed level here always, but when we adjust the voltage on this connection, it then adjusts the RF attenuation going through. So depending on what voltage is on here, it'll pass all the signal through, or if it's a different voltage, it'll then change its attenuation, so the signal level will reduce coming through in proportion to the control on the front. But the second function of this is to modulate the carrier. Because this is a pin diode attenuator, it's also used as a pin diode modulator. So what happens is when we feed modulation in, be it pulse modulation or sinusoidal or square wave modulation, it arrives on here, and it modulates the RF amplitude for going out, which is particularly useful for radar applications and things like that. And with this particular piece of equipment, it was originally came from the Ministry of Defence, belonged to HMS Southampton of all places, so it's obviously had a life it's obviously being used in a defence application at some point, possibly for testing radar sources or whatever. But anyway, this filter here then, it looks like it's a filter anyway from what I can work out, passes the RF signal out to the N-type at the front. So this level control, when I checked it when it first powered on, does not work. It just provides a continuous output from the N-type at the front without attenuating it with this. But that could be down to this PCB shenanigans. So we're going to fault find on this. We'll download the service manual and we'll try and track down. These are just 741 op amps. All the capacitors are old, you know, shot. I mean, the donkey's years old. And the thing is that the values are all wrong. So we're going to change those. I'll probably change this big electrolytic capacitor as well. It's not showing any signs of leakage or anything, and it measures okay. But just due to its age, it's, you know, it's older than me, that. So we're going to get that changed. As for the IEC on the rear, which doesn't have a filter arrangement, and thus the reason why I think this person who repaired it before me had put these reefer caps in, then, you know, modern day stuff, if we move to the 21st century, we have things like this now which have all that integral. We obviously have the internal filtering, as can be seen by the diagram on the top. So that gives us the filtering for mains, and essentially it's got the reefer caps built in there on that part between the output live and earth and neutral and earth. So we'll install one of those, and then the other thing as well that's I've noticed, there's been a bit of a bodge with the soldering. I don't know what the heck it was done down there, but as you can see, that SMA connector there has definitely had a bit of a bodge soldering on it. I mean, it gives an output, so somebody's obviously been faffing about. And there's also an RS capacitor here, and that's a newish capacitor. Is that? That's not a capacitor which has been fitted from the 1970s, 80s. That's a new RS one. So I'm gonna see what it says in the diagram about that in the service manual. But one of the interesting things about this, which I do like about it, I must admit, whoever thought this out was really good, is that not only do we have a mechanical frequency control, but we also have a potentiometer down there as well, where we set the mod level, which is this potentiometer down here. But how it works with the way that they've limited how it limits is this little arrangement here, and I find it quite fascinating. You can see there that there's a tooth stood off there, and what I like about it is when if you look at the cog on the left, you'll see see if I can get in on it. It's difficult, but you can see just sort of, where is it, just there's a stud. It's quite difficult to focus on it, but there's a stud, and when it mashes with this, you can see there's another stud there, look, which is just there. You can see it there, that stud, and then another one there, which you can see at the top. And what happens is that tooth there that's stood out, it makes it miss. It just misses every time it comes by. It just jumps one tooth further in. So in other words, this sort of notches that way every time it passes that tooth there. So what happens is it doesn't mash up against those studs on the left cog until it reaches the end frequency, and each time it revolves, turns a full, it jumps the cog. So that stud there, this jumps a tooth on this cog every revolution until it gets to this notch, this stud, and then it mashes it, you see, won't turn anymore. So that's for the lower frequency range, if you like. And then likewise again, as we turn it, it then mashes against the other one eventually. See, each revolution it skips a tooth until it gets round the cog on the left, until it mashes again with that. Very clever indeed. Lots of mechanical engineering thought, and the quality and the build standard, as you can see, brass cogs, spring loaded, you know, this is spring loaded, the cam for the control of the plunger in and out of the oscillator, you know, it's well thought out. You don't get things like this anymore, you know. Somebody who obviously designed this had electromechanical design knowledge, and not just electronics or RF engineering knowledge. And to calibrate this as well in relation to the frequency on here, the mechanical sympathy and the synergy between the readout on the front and the plunger and its relationship to the frequency versus obviously what's on the front here is fascinating, because that takes a lot of thought, that does. That's not something that, you know, can be easily designed unless you're very knowledgeable of mechanical dimensions of cogs and the torques, and obviously the circumferences, and it's linked in relationship through the system. You know, what we do at the front ultimately ends up with either a small adjustment or a major adjustment here, which then directly is proportionally related to the frequency output versus what's read on the front with this mechanical thing, you know. I mean, it's been very well thought out. And obviously, it's older than me, this thing, practically, I think, so this is very good quality. I mean, you'd be challenged to find anything that's manufactured in today's standards that will last 40 odd years, you know, like the day it was new. And there's no wear in any of the cogs, there's no nylon cogs, none of this crap from the Far East that you find today where it lasts a year and then it's bin fodder. You know, it all works properly, you know, as it should do, and it'll be lasting another 40 years after I've finished with it. But yeah, so a bit disappointed that somebody's had a go at it before me, and obviously made it worse in my view, but we'll sort it. And the circuit board, obviously I'm going to replace all the capacitors. I'm not sure about 741 op amps, one of them might be blown, because I've looked at just briefly at the way that the circuit operates. None of this surface mount rubbish, you know, it's all good quality electronic components, and you can adjust things as well. Look at that, you can do all these adjustments without any fancy stuff. And the other thing about it is as well is that it's so easy to fault find. Obviously, you know, there's a service manual for it, we can fix it. You know, this ain't going to end up in landfill like a lot of consumer electronics today does. You know, the way of the world now is that we don't repair things, and this is a great disadvantage, and this is why we have such a problem in the world at the moment with e-waste in particular, and ending up in places like China and India and other poor countries where, you know, we dispose of our everyday electronic items. You know, wasn't that long ago, 20-30 years, maybe 40 years ago, we had a thriving repair business in the UK where people repaired things to component level, tellies, videos, hi-fi equipment, anything, washing machines, you name it, mobile phones even, we repaired those to component level at one time. And you wouldn't be seen throwing a mobile phone away 12 months after you'd purchased it. If it failed, you took it back to the Vodafone repair centre or Cellnet or O2 repair centre, and you would repair it to component level. And that is indeed what I used to do many years ago when I was a young'un. But these pieces of equipment need to be repaired and kept going, and I think it's the same with any electronic item, you know. Only dispose of it if you can't get parts anymore, or that it's not possible to repair it for whatever reason. But I remember my workshop was full. I had a library in my workshop full of service manuals and books for test equipment, and you just don't see that anymore. And then when we went to, you know, with some computers and everything with PDF files, we had service manuals and circuit diagrams then transposed over onto CD-ROM, and you know, all the service guides, things that came out from Sony, Panasonic, Marconi, and NEC, all the big manufacturers, HP Agilent, Road and Swartz. They were all, you know, all produced service manuals for the test equipment or for any product that they manufactured. And you know, you could repair things, and you went on repair courses. You know, I used to go down to Sony in Thatcham, Newbury, Thatcham Way, Vodafone, Panasonic, NEC. I used to go all over the place. Pine Phillips Telecom in Cambridge, Cleartone in Wales. I used to go all over, you know, on training courses and learn how to service their products. And you know, and there was an entire living and career to be made from repairing things to component level. And people paid to have the tellies repaired and the videos. You know, you didn't just bin it and then buy something new. And then we wonder why we've got the problems that we've got today, with the way things are in the world. So, you know, again, I think we need to go back to this repair, recycle, don't throw away. And this is another reason why I like collecting electronic components as well. That a lot of manufacturers of equipment or repairers that are long gone now would like to dispose of componentry that they've got, ICs, transistors, you know, RF components, things like that, and I actively go and source them and keep them and stock them. And that's why I have many thousands of old germanium diodes and transistors that are very rare indeed, and RF transistors that have long gone, you know, that you know, collectors need and people that restore pieces of equipment need. And so I have the fortunate position of having mass stocks of electronic components of yesteryear as well for that reason. But yeah, it's a nice little microwave signal source. I think it was used for radar applications on board this HMS Southampton. I'll have to look up the ship and see what it looked like. And I'm assuming it's a ship. It might be just the naval dock thing in Southampton. It might just be known as HMS Southampton. It might not actually be a vessel. I don't know. But I'll do some research on it and see what HMS Southampton is. So with that, I'll come back to you with a second video after I have got the neon in and the filter arrangement, and then we'll start looking at the fault in the service manual when I printed it off for the PCB that controls the oscillator and the pin diode attenuator. And we'll go through a bit of a calibration procedure, frequency and level, and we'll do all the calibration that's recommended in the manual. So that'll be part 2. So thank you for watching, and I'll see you in the next video.